Hello, I'm Mark Everline. I'm the inventor of the Screwsaver machine we have here. Finally found an opportunity to use the Screwsaver machine for something in our shop. We don't have many stripped out sockets and hex drive screws because we have this, but still sometimes you get lucky, and so today we found a screw that's stripped out and we can't get it out using a regular hex drive or Allen wrench. So we're going to go over here and take a part off and repair it. So we have some tooling over here that has a stripped out hex drive screw in it. And as you can see, we can't get a bite on the screw in order to be able to take it out. So, perfect opportunity. So we will remove this. We're going to come over here, and as you can see, there's a stripped out screw over here that doesn't allow us to get it out. So how are we going to accomplish that? So what we're going to do is we're going to take our calipers and figure out what size this is. The good one is 163 thousandths in size. What we want to do is we want to take this hex driver key and we want to make a driver that will remove that stripped out screw. So the first thing we need to do is determine the amount that we want to have the blade sticking out so that we can remove the screw. So we know the distance from here to here and here to here, and from the face of this feed cradle to the center of the cutter is the same. So there is a screw right here that we can set the length with. And we can open it up and make it a longer length of cut on a blade that we would manufacture, or we can put it in less. I'm going to start about right there. We're roughly set up, so we will insert what we call a chuck sleeve with a chuck on it into the setup cradle. It's guided by pins. And we can put a hex driver into here, into the setup cradle. Now these things don't always line up. As you can see, we have a hex key and we have a 3-jaw chuck here, so that means we can hold a 6-sided object. But it's not going to be lined up parallel with our machine. So if we want to adjust that, I loosen this screw, and that allows it to turn on this ring, and it allows us the opportunity to adjust it for the amount of protrusion we want to have here. I'm going to lock this in. Now I'm going to slide this ring forward. There we go. And now I want to align the key so I can rotate this until it's parallel with the surface and kind of eyeball it here on the setup on this V block. Now I can lock it down and we are ready to start grinding. So this sets our length of protrusion and also our length of cut. So we're now going to rotate this around. By the way, this knob over here moves our adjustments up and down, and as you can probably see with this dial indicator, this tells how far we're moving it up and down, and that's our guide. We can either use a stone. These are made specially to our dimensions and our specifications so that it cuts fast, cool, and doesn't burn. This is a carbide cutter. It's a double cut burr. I highly prefer this. It cuts fast and easy, and it cuts very cool. In order to get a 6-sided cut, you have to have 6 holes. So there's 1, there's 2, there's 3, there's 4, there's 5, and there's the 6th cut, giving us 6 sides that we've cut. So we want to be somewhere in the neighborhood of 163 thousandths across, and this one happens to be 187 as the raw size. So I'm going to insert this. I'm going to back my cutter out and turn my motor on. And now I'm going to go in and I want to get it set up to where it just barely starts cutting. So I'm going to lower the cutter down. There we go. Okay, so now we've started our cut. All right, good. I'm going to turn the machine around one more time and show you one more thing. So this is the point where we are zeroed on our cuts. So I'm going to start right here with a 0. And as I move this dial up and down, that'll give us our cut. So we're at 187, 3/16 blade. We're at so we're going to have to take off about 10 thousandths per side on this blade. So we're going to start in. We turn it on. And now I'm going to lower it down a little bit. So I'm going to take it down 5 thousandths. As I'm doing this, I put my thumb on top of the sleeve, I push down and I rotate it to one side. It takes the slack out and gives us a much better and closer cut. So let's check our progress here and see how we're looking. So we're down to, we've squared it up to 174 thousandths. So we'll take it down another 10 thousandths. So I'm going to lower my cutter down again. That's 1. That's 2. That's 3. You probably expect that this is getting quite hot, but it is not, because that cutter acts like a squirrel cage fan and it cools the cut. So we don't have a great fear of burning a tool here. I want to check it again. See when we get close. There we go. Now we're starting to get into it. If we're, I think we might have it. Let's turn this off. We're down at 166 thousandths of an inch. So let's see what we got over here. Can we get this thing into here? Now I can bear down on this thing and kind of push it in to get it to really fit down in place, and there we go. There's a bad screw. Garbage can. I think we have a new one. Here's a new one that we've already set aside. So now we can take our standard driver and put it back in here and tighten this thing back up. And that is how you fix a stripped out hex drive screw.